As mentioned, my name is Devon Stewart. I'm going to be talking about practical code gen. It is. You will. Good. Hey, you did it. I love Scala Meta. I'm not going to hide it. It is one of my favorite tools. I've been using it aggressively for the past 5 years. I wrote a tool called Guardrail. Guardrail.dev is where you can find it. It is a compiler that uses abstract syntax trees internally to transform OpenAPI into Scala and Java that you would have written. It's not domain like craziness. Just trust us; it'll work once you just don't look inside the bag. No, you can actually use it in your project, and you can actually trust the code because it doesn't have nulls, it doesn't have exceptions, and it's all as ideally as you would have written it. So, as a result, let's go over what we're going to cover in this talk. First of all, why would you want to use code generation when you've got tools like macros, you've got tools like an army of developers that you can just stick on a project? Why would you try to automate things? That's a good question. I'll answer that. Additionally, why is this little box here? These are good questions. Oh, hey, little box. All right. What is Scala Meta? How do you use it? Why is this library the one that I'm putting my weight behind? Why am I trying to get more people excited about the tool? What's going on with it? Our straw man for this talk is building case classes from scratch, starting with a Pojo, adding the Scala magic on top of it in order to get to where you need to go. You want a copy method, you want toString, you want all that stuff. You don't want to write it yourself every time. And then we're going to extend it with some real-world kind of business domain things like JSON deserialization. We will do that, as well as some, let's say GDPR as an example. GDPR, some may be familiar with it, cause a lot of problems because default toStrings for things like case classes just leak all your sensitive private data that you don't want showing in log files. Let's just code generate solutions that don't even have that problem to begin with because they don't have a default toString that you have to override. So these are some of the motivations that we attempt to cover in this talk. Let's take a look at the first thing. The way that you get Scala Meta, it's just a library. It's not it says meta in the code because it is a meta library that describes Scala. It is not actually meta programming in the black box versus white box or all the new fancy stuff they got in Scala 3. It is none of that stuff. What it is pretty great. I'm going to show it to you now by way of the REPL. The important thing is that normally if you're writing a code generator, you would put your Scala Meta dependency inside your build.spt or something at the top level. But because we're writing a bespoke plugin in this project that is supposed to code generate code in the actual project itself, we're actually putting it in the Scala Meta.spt that's one level up in the project. If you're familiar with SPT, SPT is actually a meta project structure. So each project has code that compiles the previous level of Scala or of SPT. So you can actually stack your environments together. So we're going to use this in this talk. In order to get a REPL with Scala Meta, though, I have to switch to the next level of SPT. It's turtles. Anyway, the point is, console quick is what we want. Scala Meta is great. I will show you exactly why it's great. Import scala.meta _. Let's say I want a function called foo that has an argument that's an int, and it returns a string. And I will say a.toString. That's a great function. But how does Scala think about it? Scala actually thinks about the structure of what that thing is. This is the internal representation of Scala as a domain language. If you're familiar with Scala Meta, apologize, we're going to get to something interesting. If you're not, these are some cool things you can do with it. First is you can actually set it to itself. It won't actually do anything because, sure enough, x is equal to that statement. But you can also use it to extract from itself some bindings. So I can actually extract the body of this function entirely in the REPL and use that to iteratively build up a completely new structure. So if I were to say body is, let's say, let's do hello world, and then try to render that, you can see that I actually get the def and def foo, a int, string, hello world. Just all in the REPL, just using the power of Scala Meta's quasi-quotes and the apply and unapply. It's got amazing syntax for that. So now that you're familiar with broadly what you're capable of doing, let's see it in action. So let's pop over the next slide. We need a way in our plugin. The intent of this talk is to show you how you can add Scala Meta and source code generation to an existing project. So you've got something in your code base already, you've got a lot of boilerplate, or you've got stuff that's kind of a little bit divergent and you'd like to kind of pull it all in together. This is the talk for you. You can actually find this talk. I should have probably called this out. You can find this talk at, for those who saw that, the Blast Archies /talks on GitHub. All the code for this, including all the slides, is all available, so please go check it out. We will pop back over to here. So if we're going to be generating this thing in this project, we have this bespoke plugin.spt. I need a task that I can hook into the SPT code generator. I also need a way that I can render Scala Meta source trees into Java files. I have that here, write files. We're not going to really talk about the details of that. It is literally just writing files. It's very simple. And then the last thing is the emit sources here. This is where we're going to do the bulk of our work. It takes in a Scala managed sources path and then allows you to, this is just something that I put together here. You can alter it to your needs. But in my case, I want to be able to take a Scala Meta source tree and I want to be able to put it into a file. So let's look at what that looks like in a real world situation. If I have a, let's say a Pojo class, Scala, whatever, that is just foo, it's got two parameters. It's got A and B. It's got the accesses to that, and it's got a basic toString. In Scala Meta, because we saw the quasi-quotes, the string interpolation in the AST, I can actually talk about, oh, I should mention AST, abstract syntax tree. I think that I mentioned that before, but if not, now you know. I'll say that a lot because that's what this Scala Meta, the concept behind Scala Meta in this case. We're talking about the actual structure of Scala, not necessarily the syntax. We're talking about building and constructing and deconstructing the representations. So in this case, I'm just putting a function called build toString into some object in my generation, my codegen path. It's just like project /source/main/Scala. It's like anything that's on that path I can access within this code generator space. And I want to be able to get a toString like this that's emitted. I want to be able to get something that's like the class name, A equals this, B equals this, commas in the middle, like all that should be nice. So let's look at what that actually looks like. In like reality, this actually looks like this, where it's dense, but this is not unreadable Scala. If I take the parameters, it's a list of Scala Meta parameters, it maintains the structure of what those parameters are. So if I, on the third line here, val fields, if I take the parameters and I case, if I destructure the parameters using this case, I can actually pull out the term, which is a term name, and I can pull out the string, this field. And so I can actually create a string literal called like A in this case equals, and then the actual body of the thing is term.toString, which is great. Those watching who don't see this screen, I'm just going to be going off to point at the screen. Sorry. But anyway, once we actually have all of those fields, we can think we've got A equals this, but we just got a list of those things. We need to be able to know them together somehow. I like commas. Commas are great. Let's take the fields themselves, fold left. If we don't have a field, then we just have none. So we don't need to add a comma. If we do, we add a comma. You know, there you go. And then slam a open paren and a close paren on the thing, and you've got your toString. This override def toString string, that is actually what we need in order to make the project work. So we will see what that looks like now. Reload to actually load our project into SPT. and I can run, and I will actually see foo a equals 1, b equals 2. This is real live code using the code you just saw. So here we are, going on to the next one. I hope that this is not going too fast, but I also need to conserve a little of time here. So my apologies, feel free to ask me questions after. The next thing is, in Scala, we like being able to say foo parens and then supply all the arguments. We don't want to put new everywhere because, Scala. So let's make an apply method. Very similar. We just need to be able to say, I'm going to take the structure here, and I want to be able to interpolate those things. Because I'm using these quasi quotes, I can actually just do that. So it looks basically exactly like that, except for there's a bug. And so there's a Scala meta issue called out here. I created the Scala meta issue probably about 4 hours ago. So sorry, there's a bug. But other than that, the only thing that makes that bug unfortunate is you have to use the unpacked structure instead of the nice quasi-quote to do this thing. But other than that, it is exactly what you would expect, and it lets us get rid of that pesky new in front of that foo object. So let's pop the next slide. Copy, super useful. I want copy as you would have in an idiomatic Scala case class. I want to be able to say foo, some parameters, dot copy, a equals this, b equals that, or leave off the a, or leave off the b, or leave off both of them. I want to be able to do that because I think it's cool. So if we look at what that looks like, this is the definition of that. All we have to do is take in our trusty parameters, and we just iterate over them and translate them from one structure into a different structure. In this case, we're transforming them from a parameter that is just a colon int into a colon int equals this dot a. And so we do that by destructuring the param and then repacking the param, as well as destructuring the param and then making the default be a equals a, b equals b, like just to make it all kind of fit together. But your copy definition then becomes copy definition, very similar to what you would expect from just plain string interpolation, except that this is all very real Scala objects under the hood. This actually maintains the structure of the Scala code, like how this is all knit together. So let's just kind of move on to JSON encoding and decoding. In this case, just the decoder, but you can see what this would look like if you were to just magically make all of the case classes that you were generating using this code generator automatically come with JSON serialization and deserialization. You might want that for some reason. The way to make that happen is if you had, let's say, this giant block, there. So if you had this whole implementation of an implicit decoder that you slam into the companion object, you could write that thing. The way that I would do this is I would write the code that I want to get generated. As an example, I would actually do exactly this. I would just, let's do that, and through the magic of Vim key bindings, we can actually reload plugins, we can console quick, we can import Scala meta, and in a quote, I will actually just paste in exactly that code. And you can see that reso structure actually is, I just took the Scala code that I wanted to get generated, and I put it directly into a quasi-quote, and now I can actually talk about the actual structures. I can talk about packing, unpacking, restructuring this whole thing. I can reformat this to what I want, but you can actually do this iteratively in the REPL. I think the REPL is an underutilized tool in this sphere. Highly recommend. It is very convenient to be able to see what Scala meta thinks the structure looks like, what Scala meta actually thinks the code is, and then being able to say, so I've got a for comprehension. Scala meta has this enumerator generator that binds the parameter a to this value that decodes that thing, and then puts all the generators together into a for yield, and then this is the result of the for yield. Sure enough, that is almost exactly what we have here. There's the for yield, there's the value that is the term name gets assigned parameters. That is the structure. So if I do this now in this generic way, I could actually look at, let's say, the the build, the bespoke plugin that we wrote before, at the top, you can actually see, I actually forgot to call this out. This is how the Pojo objects are described. So this foo and then the parameters that I've supplied, this is where the source of truth is for this code generation specification. I just have a function, and I'm calling a function, and I get code generated and stuck into the source managed file. And just because of that, I can actually reload, I can run. If I delete that, just to prove this, I can reload again, I can run, and then it'll say, hey, by the way, foo does not exist. Okay, great, so let's add it back, reload, run, and then it's back. It is actually, this is before your eyes. Go use it, it's good. Yeah, exactly what we were just saying. This is the actual full code. It's a little bit longer than I have on the slide, but it's only because I have to account for things like for yield doesn't like null bodies. You have to have at least one binding, so you have to, okay, so I don't have enough bindings, so I can't do all this stuff. I just have to emit the structure as itself. And then if I try to decode something that doesn't have parameters, then it just decodes as successful. Great, awesome. So last thing I'd like to talk about here is, actually second to last thing, sorry. Second to last thing is adding more of these things. We've got foo, but my domain requires that I have baz and bar as well, because you have to have all three of them in a Scala talk. So as a result, I just put together some new parameters. The last one is list empty. That's just to catch the base case to prove that prove everything works. So compile, first of all it runs. Run, you can see NeoVim has detected that a file has changed. Let's look at what these files actually have. Sure enough, foo has what we expect. It has the apply, it has the JSON decoder. It also has a copy method, and it has toString. Going to bar has the exact same stuff, except it has one more parameter as C. And then baz has the exact same stuff, except it has no parameters. So this is should prove that all of these are being generated, and also, yeah, I only had to write one, and now I get all the rest of them for free. Last thing is, I want to be able to say, second to last thing, sorry, the last one was third to last, this is second to last. Adding an additional parameter, I've changed my business requirements. Now I have to have C in foo as well, not just in bar. So I add C to foo, and then I'm able to reload and then run. Sure enough, it's able to decode. I get A, B, and C. This is some foo, because this is actually now round-tripping through JSON. Not round-tripping, it's decoding from JSON. I didn't write an encoder for this talk. All the talk is self-contained. I'm not using a real JSON library. I came up with an enumeration and just put them on there. But this is mocking an actual JSON decoder, what it would actually look like in production. Last thing is field redaction. So I mentioned GDPR requirements. Man, that caught everybody by surprise, didn't it? Yeah, no, it did not. Yeah, well. So I can tell you that a company that will not be named had problems. So as a result, being able to say, well, let's not do that, would have been much easier than having to chase this down for literally months. So the way that I have accomplished this here is by having a redacted fields list in our generator that turns out to just stub out the toString. If that field is redacted, then we just put 3 asterisks and be done with it. So much easier than millions and millions of dollars of fines. That's it. So, all of this is in jest. None of that actually happened.
Just first and foremost, we will be sending out the GitHub page for you guys to check out if you did want to take a look at the guardrail API or anything else that Devon's done. I know I said to hold questions, but Devon's actually got to run, so I'm going to open it up for a couple of minutes, let you guys get them out, and then we can let Devon get on out of here.
You've also pointed out one thing. It's just a quick point here. I mentioned earlier that I've been using this style of code generation for the past 5 years. It is part of this project Guardrail. Guardrail, the OpenAPI code generator, I use this heavily. I really would appreciate going and checking out guardrail.dev. We get a significant number of downloads per month on Sonatype, the Maven Central. And additionally, I am. Is the plug okay for myself?
Plug away.
Okay, I'm accepting contracts for adding features or helping your company adopt Guardrail. It has worked tremendously for a number of companies. I know that at a time, Disney Streaming was using it. Avast uses it, or has used it in the past. I haven't checked in with them for a bit, but a non-trivial number of users have used it and continue to use it and seem to like it quite a bit. And I hope you will too. So, yeah.
The string interpolator on apply,
Yeah.
like matching and the AST DOM, are all those part of Scala or Scala Meta?
Scala Meta. So
Okay.
that's the queue, the param, the they've got a couple other ones.
Mm-hmm.
They're all off by one.
All right.
Go
So
that
anyway,
way to join this one.
yeah, if you import scala.meta._, you get all that stuff.
Okay.
It's all built into the string interpolation stuff that's part of Scala itself.
Right, and does it compatible with Scala 3?
Yes.
Oh, cool. One
Yeah.
more question. How does it work outside of SBT?
Outside of
Like
SBT
you linked into like SBT's generation
Yes.
step. How is that going to work well outside of SBT?
Yes. So, first of all, as evidenced by the fact that my project Guardrail has SBT, Maven, Mill, and Gradle generators, this concept scales to your build tool. I haven't tried Pants. I don't know, whatever else, but whatever. Those are currently supported. Additionally, my understanding is that Mill makes this trivially easy because Mill is just Scala functions for the whole definition for everything. So being able to throw a function, this is all Scala code. Even the plugin generation stuff, the only thing that's special about SBT is in the bespoke plugin .sbt file. This is the part that is SBT specific. I broke it out specifically so that everything else is agnostic.
Yep. Okay.
Yeah.
Okay, that's all I have. Thank you.
Yeah.
Looks awesome.
Yeah. Anybody else? Who's going to use it in the company?
Super abstract question.
Yeah.
We're in a situation where we're using OpHTTP.
Yes.
And we are probably, like many, we're thinking what we want to do.
Yes.
If we had used this, how much easier would it be for us to get this like HTTP 4S instead of where we are right now? I'm just a curiosity question.
So yeah, let's pretend that I worked at a company where I wrote this thing, where we were using an internal tool that somebody had written on top of OpHTTP, and we had exactly that problem because we wanted to migrate, and I had to motivate everybody migrating, and so I wrote a tool that did that.
Just curious, because
It's a hypothetical, surely. Yeah. Just it should probably be pretty easy.
Let's pretend you wrote Guardrail.
Let's pretend that I wrote a tool. Let's say I called it Guardrail. It did that. The main thing is there are some subtle differences, but the thing that I think is particularly compelling is I have decoupled in this is a Guardrail specific point. I decoupled the protocol from the implementation. So there are no HTTP internals that are leaked into your code or vice versa, which means that you are air-gapped from the underlying infrastructure, which means that if you're writing tests, you can actually just take your implementation, your business logic implementation, call the methods, and you don't even touch HTTP at all. Or if you're using HTTP with the static providers, you can actually turn your routes, your Akka routes, into a function that you can pass in a thing in order to get the result back from. But I also generate clients. So you can pass that thing into the client, and then you have a mock server that talks to a real implementation over real HTTP. So it doesn't bind to a port, so your tests are really fast, but then it also still speaks the whole thing all end to end, so you can actually have confidence in your tests. So I thought about this a lot. So yeah, of course. Shoot me an email.
Yeah.
Anybody else? If not, thank you very much.
Awesome. Thank you.